Okay, well, to get this inverse matrix, we've got to reduce this matrix until we have the identity matrix on the left side, and what we end up with on the right side will be the inverse. Okay? It's going to end up being reasonably messy. Okay? I mean, you're going to have numbers. You're going to have numbers. Well, you'll see. I'm not going to do them. First thing I want to do is I don't want to deal with decimals. It's too confusing. So I'm going to multiply every number in each row by 10. Doesn't change the solutions. Okay? That gives me 16, negative 2, 7, 7. And of course here it gives me 10, 0, 0, 10. Okay? Then I'm going to divide the first row by 16. Now I could switch rows, switching both rows, right, the whole row, and just divide by 7, which is a smaller number. You're going to have to divide by 7 anyway eventually, so it's not going to help. So I'm going to take the first row and I'm going to divide it by 16, which is going to give me 1, negative 1/8, 10/8, which is 5/4, 0. Okay? And then
I don't think that's 5/4 because it's 10/16.
you're right, it's 5/8. See, I got the 8 there, you gotta watch me. Okay? Last number I saw. Okay? Must be right. Okay, and then 7, 7, 0, 10. Then I'll say etc. You're into integers and fractions of integers, okay? Rather than decimals, you want to deal with fractions, because decimals end up being rounded off, approximated, and giving you errors. Sometimes that's very misleading, sometimes it's not that much misleading, but you can't rely on it until later we understand how pivots work and stuff. And we're not going to talk about it now in a 2-week introduction, okay? We'll go on and work through the details. Okay, so I'll ask you to finish inverting that and see what this matrix is.